So in chapter 6.3, we're going to be talking about inhibitors and how they affect enzyme rate. The first inhibitor we're going to talk about is called a competitive inhibitor. What inhibitors do is they actually stop enzymes from working. You can see in this normal reaction, we're going to have this enzyme bonding with a substrate. It's going to break it down. So what an inhibitor does is it comes in here and it stops the enzyme from actually performing its task or its job on the substrate. In the first example, like I talked about competitive inhibition, that's when an inhibitor is going to specifically bond with the active site. Now, that inhibitor will not be changed in any way, but it will stop the reaction of the enzyme. Again, the term here competitive means it's actually competing for the active site or like the attention of the enzyme. Now remember, the enzyme's not living. It's not like it's going to seek out and try to find the substrate. It's just waiting till that substrate is going to bond with the active site to react with it. So when this inhibitor comes in and stops that, or stops the inhibitor is going to block the substrate from coming in and bonding with the active site. You're going to stop the enzyme totally. Now, again, remember, the enzyme is not used up or destroyed in this reaction. And when the inhibitor unbonds with the enzyme, the enzyme can keep on reacting. Our second type of inhibitor is going to be called a non-competitive inhibitor. This is when a inhibitor is going to bond with the allosteric site. The allosteric site is a location not on the active site, not near the active site. It's going to be a little bit away from it. And it's going to, when the inhibitor bonds with the allosteric site, it's going to change the shape of the active site. This is because you're changing the shape of the whole enzyme, or at least the part of the enzyme where the active site is located. When you change the shape of something, you change the function. You can see here in a normal reaction, the substrate would bond with the active site of the enzyme, and it would be changed. It'd be broken down, built up into something. In this case here, you can see the inhibitor is going to come in. It's going to bond with that allosteric site, and it's going to change the shape of the active site. When you change the shape here, it's not going to be able to bond with the substrate, and it's not going to react as it normally would. Now, again, remember, the enzyme's not destroyed, and if the inhibitor unbonds here, it will go back to its original form. But this usually, again, stops the enzyme from working correctly. Again, we can see in this diagram our enzyme working correctly here. We can see the substrate is going to be broken down into two products. A competitive inhibitor bonds with the active site and competes for the attention or competes for the active site of the enzyme. A non-competitive inhibitor is going to bond somewhere not on the active site, and they're going to stop the reaction. You can see this won't occur because, again, the active site is going to change. So that's the difference between non-competitive and competitive inhibitors. Another type that your book doesn't go over of like a factor that influences enzyme rate is an allosteric activation or an allosteric activator. So just like the allosteric inhibitor, you're going to get this inhibitor that bonds with the allosteric site of an enzyme. It's going to stop the enzyme from working. The allosteric activator will do the opposite. It will bond with an allosteric site and actually activate the enzyme to work. You can see here in this case, normally this is turned off, but when the activator bonds with the allosteric site, you're going to activate the enzyme and you're going to start it to work. What this whole process, we have, again, competitive, non-competitive inhibitors, and we have activators. This allows us to do something within the cells that's really important for AP Bio. It's regulating reactions. Whenever you regulate reactions, again, you're telling reactions either to start or to stop. In regular bio, you talked about just all these different types of reactions. They all work within the cell. In AP Bio, we have to be able to understand that these reactions are regulated. They can't just react at all times throughout the day and as much as it can. We have to regulate how often things are, how often reactions are occurring in the cell.